Hello dear student, myself Kanchan Vishramji Kumbhalkar, Assistant Professor, Department of Chemistry of Shri Shivaji College of Arts, Commerce and Science, Akola. I am here to deliver a second lecture on thermoanalytical method. So let's start. This is the overall syllabus of Unit 1st, that is Thermal Method of Analysis. In first lecture, we completed with the thermogravimetry and thermogram, and different two thermograms has been completely discussed. So let's start. Now in this lecture we will discuss with instrumentation for thermogravimetry and the factor affecting TGA. Okay, so instrumentation for thermogravimetry. The apparatus required for a thermogravimetry analysis consists of the following components. First one, a sensitive analytical balance which measure the weight of sample with respect to the temperature. Means time to time the weight has been observed with respect to the temperature of the sample. Second one, a furnace which supply the heat to the sample in a linear manner, in a controlled manner. For that purpose, we required a furnace temperature controller and programmer, which is the third component of the apparatus. Fourth component is the output, that is a recorder that provide a plot of sample weight as a function of temperature, means the final result, that is thermogram. It is nothing but a simple graph between the weight of sample and the temperature. The entire experimental setup for the thermogravimetry analysis is known as the thermobalance. The overall experiment which is observed on this apparatus is considered as the thermobalance. Now the point is, what is the basic need for a good thermobalance? What are the criteria under which the good thermobalance has been observed? So first point is that the thermobalance should be capable of continuously registering the weight change of the sample studied as a function of temperature. Means with respect to time the temperature changes, and with respect to temperature the weight of sample has been changing, and that has been completely continuously registered by the thermobalance. So the first point is that the thermobalance should be capable of continuously registering the result. What result? The weight change in a sample with respect to the temperature. This is the first point to be a good thermobalance. Second point is that the furnace should reach the maximum desired temperature. For what purpose the furnace has been implied? The furnace give the temperature to the sample. Means the furnace, if we want a sample to be reached up to the 1000 degrees Celsius, this is the limit, last limit for that of the sample. So our furnace should be reached above than 1000 degrees Celsius. So hence the second point for the thermobalance is that the furnace should reach the maximum desired temperature. For example, in a commercial thermobalance, about 1500 degrees Celsius is considerable. Third point is that the rate of heating should be linear and reproducible. The rate of heating should be linear, means there is a continuous temperature has been supplied in a proper setup. For example, if you give a temperature up to the 5 degrees Celsius, then you give a 10 degrees Celsius, then a 15 degrees Celsius. So the temperature range is a linear and which is a reproducible. So this is also the third point which can be considered as the good quality thermobalance. Fourth point is that the sample holder should be in the hot zone of the furnace, and this zone should be of uniform temperature. Obviously, we heat the sample which is present in a sample holder. So sample holder should be present in a hottest zone of that of the furnace, nearer to the flame. And second point, the material, the sample which is placed in a sample holder must be placed in a such a way that the temperature must be transferred to the uh, temperature transfer to the sample must be uniform. फॉर एग्ज़ाम्पल आप देखते हो कि अगर चूल्हे में आप हीट दो लकड़ियाँ डाल दो, एक लकड़ी जल रही है, एक लकड़ी बुझ गई है, तो जो लकड़ी जल रही है दैट साइड ऑफ वेसल गेट मोर हीटेड, so the heat is not transferred uniformly, so the such thing must not be happened, such thing must not be happened in a good thermobalance. So what is the fourth criteria? The sample holder must be present in a hot zone, as well as second point is that the temperature should be uniformly distributed to the sample holder. These are the 4 points. Next point is that the thermobalance should have facility for the provision of variable heating rate to permit heating in a variety of controlled atmosphere and in a vacuum. Basically, sample does not get affected by the atmosphere. For that purpose, the sample must be placed either in a vacuum or either in uh, it can be considered as the a neutral atmosphere, for example like a nitrogen gases. So in this case the heating rate must be give a variation, means if we are giving a temperature in a slot of 5 degrees Celsius, we give a 10 degrees Celsius, then 20, then 30, then 40, this is the 10 degrees Celsius variation. So such type of variation can be maintained by a good thermobalance. So this is the fifth point. Next, sixth point, be a good thermobalance is the balance mechanism should be protected from the furnace and from the effect of corrosive gases. Obviously the material, it is having a metallic gesture, it is made up of metals, so hence because of the furnace heating purpose they may get affected. Then the gases which get evolved during the reaction, that gas can affect that metallic structure and give a corrosion that must be protected. And third point is that the furnace should be the furnace can considered as away from that of the circuit of that thermobalance. The other delicate parts of that of the instrument must be get protected from that of the furnace. So this is the next point, sixth point for that of the good thermobalance. Next point is that the temperature of sample must be measured as accurately as possible. So accuracy must be there, then it can be considered as that of the good thermobalance. For example, आपने देखा होगा कि जो लोग गोल्ड सोना बेचते हैं, गोल्ड बेचते हैं, जो सोनार होते हैं, उनके बैलेंस जो है वो बहुत एक्यूरेट एंड माइन्यूट रहते हैं. बट जैसे जैसे आप दूसरा बैलेंस देखोगे, that is not that much amount of accurate. So for in this purpose we need a accuracy, then the balance should be in an accurate way, so that must be contain a accuracy, then that type of thermobalance is counted as a good thermobalance. And next point, the balance should be sufficiently sensitive for studying small sample weight. The same ऊपर का जो point है वही point यहाँ पे भी लागू होता है. If we are measuring, for example, जो बड़ी बड़ी गाड़ियों का वेट जहाँ पे मेजर होता है, उस वेट पे अगर आप सोने की कोई चीज़ मेजर करने जाओ तो दैट डज नॉट शो एक्यूरेसी और प्रिसीजन नहीं शो करेगा. सो द बैलेंस शुड बी सफिशिएंटली सेंसिटिव फॉर स्टडिंग स्मॉल सैम्पल वेट एज वेल एज it gives the accurate value. Okay, this is the criterias for the to be a good thermobalance. This is all about the criterias for that of the good thermobalance. So now we are dealing with that of the actual instrument. A wide range of commercial instrument is available and all of these have many common features. The instrument shown in figure 1.3 employs the principle of null type balance, which incorporate a sensing element that detects changes in deviation of balance beam from its null point. Now this is the TGA apparatus. Now in this TGA apparatus, what we observe, the thermobalance consists of a beam with the weight suspension W from one end of the beam and the sample S. This is the beam. बीम के एक साइड में वेट रहेगा और बीम के अनदर साइड में a sample holder has been there. Sample holder contain a crucible suspended from the other end. The sample is enclosed in a force F, which can be heated to any specific temperature by controlling the temperature adjuster T. The temperature of furnace is continuously monitored by the thermocouple H, whose signal is applied to the x-axis of the recorder R. Weight changes are registered by an arrangement consisting of a pair of photomultiplier P, a shutter D connected to the balance and a lamp L. Means, in simple way, there are the beam, weight and sample holder. With respect to the heating, when there is a heating takes place, the weight of compound decreases and this photomultiplier detect the change in weight and that has been get recorded. Once an initial balance has been established, any change in the sample weight will cause the shutter to deviate from its original position so that the light falling on each photomultiplier is no longer equal. The resulting imbalance in the photocurrent is amplified and fed into the coil C, which is situated between the pole pieces of a permanent magnet M. This causes the coil to rotate and to restore the balance to equilibrium through the torn balance Q. Which passes through the pivot point of balance. The current is proportional to the weight change in the sample and is recorded on y-axis of the recorder. Thus, a plot of weight versus temperature, that is the thermogram, can be obtained on the recorder. This is the block diagram of TGA apparatus and its working in short. This is the overall explanation and its working. Now next point is factor affecting TGA. Now there are basically two factors. First one is the instrumental factor and second one is the sample factor. So in a TGA instrumental factors, there are three sub-factors which govern the thermogram. First one is the heating rate, second one is the furnace atmosphere, and third one is the crucible geometry. So let's start with the heating rate. Now, heating rate, if the sample is heated at a fast heating rate, a narrow region of constant weight might be recorded as an inflection rather than a plateau. On the other hand, if a very slow heating rate is employed, the time taken for record a thermogram will become too long. Hence, in practice, in a regular way, an optimum heating rate of 5 to 10 degrees Celsius per minute has been employed. फॉर एग्ज़ाम्पल हीटिंग रेट को समझना है तो क्या कहेंगे. फॉर एग्ज़ाम्पल आपने कुछ कुछ गैस पे रख दिया, सपोज सब्ज़ी डाल दी और गैस चला दिया. इफ़ यू आर स्टार्ट अ हीटिंग रेट, आपने गैस फुल कर दिया तो वो सब्ज़ी जलने की चांसेस ज़्यादा रहती है. सो इफ़ यू मेंटेन अ हाई हीटिंग रेट, then the reaction occurred suddenly and you get there is a inflection there rather than a plateau. So वो simplify नहीं कर पाओगे आप, rather than in a if you are considering a high heating rate, then it get complicated. The reaction happened within a second, बहुत जल्दी रिएक्शन हो जाएगी. वो सिंप्लीफाई कर नहीं पाओगे कि कब द रिएक्शन हैज़ बीन ऑकर्ड, व्हेन द वेट लॉस्ट, व्हेन द वेट बिकम स्टेबल. सेकेंड वन इज द वेरी लो. फॉर एग्जाम्पल वही एग्जाम्पल लेते हैं, अगर सब्जी डाल दी और गैस इतना स्लो कर दिया कि वो पक ही नहीं रही है, तो दिस सच टाइप ऑफ रिएक्शन इज कंसिडर्ड एज ए टाइम कंज्यूमिंग. So, on the other hand, if a very slow heating rate is employed, the time taken for recording a thermogram will become too long. Hence, in a practice, generally 5 to 10 degrees Celsius. 1 minute में 5 to 10 means 5 degree Celsius लिया, तो after 1 minute the 10 degree Celsius or 15 degree Celsius, the gap of 5 to 10 degree Celsius has been maintained in a regular and linear way. Such type of heating rate has been preferable. Means the first instrumental factor which affect the thermogram quality is a heating rate. So the heating rate must be linear, reproducive and in a moderate way. Next point is the furnace atmosphere. For example, we measure a weight of a, for example एक chemical एक compound ले लिया या फिर एक material ले लिया जो आप विंटर के वक्त मेजर कर या समर के वक्त मेजर करते हो, एंड द सेम क्वांटिटी ऑफ मटेरियल इज मेजर्ड इन दैट ऑफ द रेनी सीजन. बोथ शो अ डिफ्लेक्शन. व्हाई? बिकॉज द एटमॉस्फेयर इज डिफरेंट इन बोथ द सीजन. सिमिलरली द एटमॉस्फेयर व्हेन यू आर ऑब्जर्विंग ड्यूरिंग द प्रोसीजर must not affect. So hence the inert atmosphere must be maintained, which give a accuracy in a thermogram. For example, the nature of atmosphere surrounding the sample in a furnace can have a marked effect upon the temperature of the decomposition state. An important condition is recording the thermogram is to maintain a constant atmosphere for the sample. This condition is achieved in many thermobalance by heating the test sample either in a vacuum or alternative way is in a inert gas like nitrogen can be maintained through a continuous supply of gas. So to give a accuracy, there is no deflection must be maintained due to the atmospheric effect. Hence in such cases either you maintain a vacuum or either the supply of nitrogen inert gas has been takes place. So in this case you get a same result without affecting the atmosphere. And the third and the last instrumental factor is the crucible geometry. In this case, suppose we take a saucer और एक छोटा छोटे एक कटोरी ले ली और एक प्लेट ले ली. In both cases, the surface area, open surface area in plate is more. Hence, the material get cooled easily and fastly as compared to the another instrument. The similar effect has been observed and identified in the geometry of crucible. The geometry of crucible can alter the slope of thermogravimetric curve. Generally, a flat shaped crucible is preferred to a cone shaped one because the diffusion of any evolved gas is easier with the former type. Suppose we take a suppose flat shaped crucible is considered as a more preferable as compared to the cone shape. If we compare what happened, if we take a flat and if we take another example in a cone, in when reaction happened and the gas evolved in a flat crucible, the evolution of gases takes place sudden at that particular temperature. So we get a accurate point at what temperature the maximum gas get evolved and what is the weight remain. So it gives the much more accuracy as compared to the cone shaped, because in a cone shaped some amount of gas get liberated and some remain because of its geometry. Hence, the geometry of crucible also a precious point regarding the thermogram quality. Next point is that of the sample characterization. Thermogravimetry results are governed by the weight, particle size, and the mode of preparation of sample. So basically, the quantity of sample must be minimum and the molecular size must be very small. A large sample can often create a deviation from linearity if the temperature rises. This is true for the fast exothermic reaction. A large volume of sample in a crucible can impede the diffusion of evolved gases. For example, you take a large bulky amount of compound in a crucible. It get heated, but because of the more quantity, bulkiness of that compound, the gas cannot be evolved easily. So that gases which must be get evolved, that has been trapped in the sample and they face some difficulty to get evolved, due to which the characterization of thermogram has been get deflected. So for that purpose, the small sample weight is desirable for that of the thermogravimetry. So a large volume of sample in a crucible can impede the diffusion of evolved gases through the bulk of the solid large crystal. Hence, the other sample may swell, foam, and even bubble. So, the quantity of sample, size of particle must be very small, and it is a desirable for that of the thermogravimetry. So, this is all about the factor affecting the TG. So, in the next lecture, we will start with the application of thermogravimetry. Up till then, take care, be safe. Thank you.